Now let's solve these questions. So again we are solving the examples where we get infinity by infinity form. So if you observe this, limit x tends to infinity, x square plus 5, x square plus 4x plus 3. Now if you try to substitute this infinity over here, you are going to get both in numerator and denominator in infinity. So how to solve it is, see, one thing is you can apply L'Hospital's rule, but then since both the functions are of polynomial type, and you can try pulling out something as common, just see if it works. Now if I pull out x square as common, then I get this function, and if I pull out x square as common in the denominator, I am going to get this function. X square and x square gets cancelled, and now you are going to get 1 and 1 in the leading term, right? So if you try to put infinity over here, it is going to be 0, 1 by infinity, 1 by infinity, 1 by infinity. Therefore you are going to get this. You know how to understand this one is, whenever both the powers are same in the polynomial, numerator and denominator, you can pull them and cancel them out, right? And you can eliminate such questions, okay, whenever limit x tends to infinity is given, okay. And this is a combination of both polynomial and trigonometric functions. If you try to apply infinity over here, you are going to get infinity by infinity form, right? So again, for this function, sometimes you might need to apply L'Hospital's rule, right? And otherwise what you could do is, instead of using L'Hospital rule, you can just try pulling out something as common, this x, and see if you could minimize it. Now if I try that, see this, if I pull out x as common, I am going to get x minus sin x by x, and if I pull out x as common, I am going to get x into 1 plus cos x by x, x into 1 minus sin x by x, x into 1 plus cos x by x. I will cancel out the terms x, and now if you observe this, sin x by x is there, and I am going to substitute infinity there, right? What is sin infinity? Whatever the value of infinity is, sin value is always going to lie between minus 1 and 1, isn't it? Therefore here you are going to get minus 1 and 1. It is always going to lie between these two factors, and the denominator is going to be infinity, so overall it is going to be 0. 0 multiplied with a range of minus 1 and 1, isn't it? See, denominator is infinity, you can take it to numerator, which is 0. Now 0 is multiplied with this one, a range of minus 1 to 1 values, whatever it is going to be 0. Similarly, you can apply the same logic for cos x. Cos x is also going to always lie between minus 1 and 1. Whatever the value of infinity is, you are going to get 0 here, the entire term, right? So again you are going to get 1 there. Now if you look at the next example, it is logarithmic, so there is no other way you can solve it. Only option is go for L'Hospital rule. If you go for L'Hospital rule, you have differentiate numerator and denominator. Yes, when I differentiated it, I got this expression, and after differentiating it, you just write it in a form where it will be convenient for us to solve it. So see, once I have differentiated it and I got this one, and I am just writing it this way, okay. And now this entire function can be written as, I can cancel out this, right? And now you are going to get 2 and 2 is cancelled, cos 2x divided by cos square x, isn't it? Sin is cancelled, cos 2x divided by cos square x, right? So now if we apply limit x tends to 0, we know that cos 2x, this entire thing is 0, and cos 0 is 0, and again this entire thing is 0, and cos 0 is 0. Therefore 1 by 1, that is 1. Got it? Okay.